Welcome to Robert Morris University Math 0900. This is Brianne Pernick, and we are going to work on Chapter 3, Lesson 1. In this lesson, we are going to learn how to translate English phrases into algebraic expressions, and also how to write an algebraic expression to compare two or more quantities and solve number problems. There are no new terms for this section, and we are now going to begin learning the new content. In order for math and sometimes algebra to be useful to you, you must be able to apply it to real life situations. One of the most common questions that I get whenever I teach a new concept, especially to younger students, is excuse me, when am I ever going to use this? Real life situations are the when am I going to use this answer to the why of why we teach this. And real life situations are often represented by word problems. So with that being said, you must be able to solve word problems, and the key to success in this area is being able to translate from English to algebra. And there are several key words and phrases that have direct translations from the written English language into the mathematical and algebraic language. And if you can learn and memorize these key phrases, the solving of word problems will be significantly easier for you. So often people see word problems and they start to get a little bit anxious because word problems are more difficult. The reason that it's more difficult and challenging is because of the fact that you have to do this translation. So if you can memorize these key phrases and then this translation becomes easier for you, that can reduce a lot of the anxiety that you can encounter whenever you see and have to solve a word problem. So the first set of key phrases that I have here for you are English phrases that describe addition. And all of the phrases that I have here for you are specific phrases that all describe the algebraic expression of x plus 3. So we have 3 more than a number, the sum of a number and 3, a number increased by 3, 3 is added to a number, 3 greater than a number plus 3. Since we do not know what the number is, we simply use x to represent that missing number, and all of the phrases that are listed in italics represent addition. And then each time we are adding 3 to our missing number. Now, addition is commutative, so we could have also written our expression as 3 plus x. However, please note that that's kind of bad algebra to write your constant first. You should always write your variable term first and your constant term second. That way you're following that good algebraic form. But just know that addition is commutative, and you can add in whatever order you desire, and you will still get the same answer. I just wanted to point that out to you. The next set of phrases that I have for you describe subtraction. And I have a big note here for you that subtraction is not commutative. So you have to be very careful about how you are writing these phrases. A number decreased by 4, 4 less than a number, 4 is subtracted from a number, 4 smaller than a number, 4 fewer than a number diminished by 4, a number minus 4. The difference between a number and 4 are all phrases that can represent the algebraic expression x minus 4. And keep in mind, as I mentioned, that subtraction is not commutative, so you absolutely could not have written that as 4 minus x. That would have been incorrect. The next set of phrases that we have here are phrases that describe multiplication. So we have phrases such as double a number, twice a number, the product of 2 and a number, 2 of a number, 2 times a number. These are all phrases that represented 2x. Multiplication is commutative, so you could multiply in whichever order you want to. Good algebra, whenever you have a variable, does require you to write your constant term first and your variable's term second so that you have the coefficient in the front. Just keep that in mind, please. And then lastly, I have some phrases up here for you that describe division. We have a number divided by 5, 1/5 of a number, and the quotient of a number and 5. And I need to caution you that division is not commutative, just like subtraction is not commutative. You have to be very careful how you set up your problems here, because if you set them up incorrectly, it will be wrong. So the next set of examples I have here are just some more examples of phrases and how they translate into an algebraic expression. So we have a quantity is increased by 5. We don't know what our quantity is, so we just simply use x plus 5. We're doubling the value. We don't know what our value is, so we're going to use x, 2x. 1/3 of the weight. Well, we can do this 2 ways. We can either do x over 3, or we can multiply by 1/3. That's up to you. Letter D, 12 more than an unknown number is x plus 12. Letter E, 7 less than a number is x minus 7. Excuse me. I would like to point out for that one that when you are using the words less than here, that's different than the inequality because the verb is not listed there. If it had said 7 is less than, then you would have used the inequality symbol like that. But since that verb is not there, we are referring to the subtraction of 7. And when it is 7 less than a number, please note that the setup of that is actually flip-flopped, just as shown here in this little diagram. And now I would like for you to try some. Please pause the recording and complete letters A through G. And as soon as you are ready, press play and we will go over your answers together. Okay, by now you should have had an opportunity to complete letters A through G, and you should be ready to go over the answers with me. Letter A, A quantity is decreased by 7. We do not know what the quantity is, so we will use a variable. You could have used any variable that you wanted to. I used letter x. So x is decreased by, that is subtraction, 7. Letter B, quadruple a quantity. Quadruple means that you are multiplying your quantity by 4. So I have 4x. Letter C, 13 greater than a value. I don't know what my value is, so I'm going to represent it with a variable. Greater than indicates addition, and I am adding by 13. Letter D, 7/8 of a number. Of always indicates multiplication, so I have 7/8 times x. 7/8 x. You may also have written that as 7x over 8. Some people choose to put the x in the numerator. Either way is acceptable. 6 fewer than a number indicates subtraction. So we start with our number and then we will subtract by 6. Now, letter F and G are two very commonly confused and mixed up subtraction problems. Please memorize how these problems are set up so that you remember which one is which, and so that you don't make these mistakes. When you have a number less 10, the word less is acting as a verb. So you are taking your number and subtracting 10. So that is n minus 10. However, whenever you have 15 less than a number, that's being descriptive and telling us excuse me, that we have our number and we have to take off 15. So please notice here that in letter G, I had to flip-flop the order in which they were presented. So the 15 was written last, even though it was presented first. Okay, that is a very, very common error in the way that people set up their problems. Okay. The next topic that we're going to cover deals with the introduction of parentheses that must be used in our expressions that we're going to be writing. Sometimes more than one operation can be described in an English phrase, and you must be able to recognize that and translate that into your algebraic expressions. Sometimes the parentheses have to be used in order to make it clear which operations have to be done first in your expression. Let's look at what we have here. Now, letter A says that we have 7 more than double a number. Excuse me. We have multiple operations that are happening here. More than indicates that we have addition happening, and double a number indicates that we have multiplication happening. So you need to look at this expression and decide for yourself, do I have to have parentheses in here? Or is it okay, according to the order of operations, for me to simply write 2x plus 7? And in this particular example, it is acceptable to just have 2x plus 7 because order of operations will allow us to take care of that multiplication first and the addition second. However, in letter B, if you take a look at that one, it says that the value of a number is increased by 7 and then it's being doubled. So if you think logically about what's happening here, first I'm adding and then I'm multiplying. That goes against the rules of the order of operations, because the order of operations tells me to multiply first and add second. This statement says that the first thing that I'm supposed to do is add, and then I'm supposed to multiply. That's backwards. So I have to introduce parentheses here, if you look at this side, so that you know that the first thing that you do is add. And the second thing that you do is the multiplication. So you put the expression x plus 7 in the parentheses, and then you put the 2 in front of the parentheses so that you know after you take care of your addition, then you multiply. Letter C. It says that 1/2 of the sum of a number and 3. This is very similar. We are taking 1/2 of a sum. In order for me to take half of a sum, that means that I first have to get my sum. So that means that the first thing that I have to do in that problem is add. And that goes against order of operations. So we have to first take care of the adding of x plus 3. So I need to put that in parentheses so that we can do that addition first. After you get that sum, then you can do the multiplication of 1/2. I would like you guys to try letters A, B, and C, and whenever you're ready, go ahead and hit play again, and we'll go over the answers together. Okay, by now everyone should have had an opportunity to complete letters A, B, and C. And we're going to now go over the answers together. In letter A, it says that a number is decreased by 4 and then tripled. So we have some key phrases here. A number decreased by 4, then it's tripled. So we have subtraction, then multiplication of 3. Order of operations would tell us to multiply and then subtract, but the then tells us that the multiplication is supposed to come second. So that tells me that I need to introduce some parentheses so that I know that I have to multiply by 3 after I do my subtraction. So my number is going to be decreased by 4 first and multiplied by 3 after. Letter B, 5 less than double a value. 5 less than double a value. I am taking 5 off of a value that has been doubled. So I'm going to double my value and then take off 5. I do not need parentheses in that expression because it doesn't, it's okay to just simply follow order of operations there. In letter C, 2/3 of a value that has been increased by 8. 2/3 of a value that has been increased by 8. So we have to have a value that has already been increased by 8 before we can multiply it by 2/3. We want our value to have already been increased by 8 before I can multiply it by 2/3. So for letter C, we do need to have the introduction of the parentheses there. If you have questions about that topic, let me know. I'll be more than happy to work with you on that. Okay, the next section here, we are going to start writing algebraic expressions that compare two or more quantities. So what I'd like you to do is pause the recording and read this paragraph for me. As soon as you're ready, go ahead and hit play. Okay, by now everyone should have had the opportunity to read the paragraph here. And what we're going to start doing is figuring out what we're solving for, as well as what's missing in our problems. And what we're doing here is, what we're going to be doing here is what's called defining a variable. And we have to write an algebraic expression that represents our situation in order to do so. So the very last sentence in that paragraph that says we usually let the variable represent the quantity that is the basis of comparison, the quantity that the others are being compared to, is pretty important there. And it's kind of hard to understand. What it's saying is that we have to figure out which quantity is based off of the other one. Okay? So I'm going to show you guys a bunch of examples here. Okay? We're going to figure out how to write what's called let statements. And let statements are very, very important when solving word problems. And they're going to be the key element that help you set up your equations. If you master writing your let statements, you should have no problem setting up your equations. Okay? So example 1 says that Mike's salary is $2,000 more than Fred's salary. The directions say define a variable and write an algebraic expression to represent the situation. So my first question is always, who is based off of who? Okay, I'm dealing with two people, so I'm going to say who is based off of who. Is Fred based off of Mike, or is Mike based off of Fred? The problem tells me that Mike is $2,000 more than Fred. So another way to look at it is, whose salary would I need to know first in order to figure out the other? If I knew Fred's, could I figure out Mike's? Okay, that's one way to look at it. Okay, so since Mike's salary is $2,000 more than Fred's, okay, that means that Mike is based off of Fred. And being that Mike is based off of Fred, I am going to let my variable represent Fred's salary. So I am letting F equal Fred's salary. This is called a let statement. And it is what's called defining a variable. It tells me and you and your viewer what your variable represents in its base form. Now, if I want to write an expression that would represent Mike's salary, we are not allowed to use two variables. We are only allowed to use one. So that means that we have to use F. So we're going to write Mike's salary in terms of F. But we know that Mike's salary is $2,000 more than Fred's. So if I start with Fred, more than means addition, and Mike is 2,000 more than Fred. So I have now written a second let statement for Mike's salary. So Mike's salary is F plus 2,000. It is equivalent to Fred's salary plus $2,000. That's what this example was asking us to do. So we wrote two let statements, one for Fred's salary and a second one that included an expression for Mike's salary since Mike was based off of Fred. Let's look at example 2. In example 2, it says that the length of a rectangle is 3 meters shorter than twice the width. We have to define a variable and write an algebraic expression to describe the length and width. Draw a picture of the rectangle and label the length and width. Our rectangle's already there, so we don't have to draw it. Now, first question, what is based off of what? Is length based off of width, or is width based off of length? So it says length is blah, 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 width. That tells me that length is based off of width. Okay, I'm not even worried about all of that other stuff right now because it's telling me that length is based off of width because it's giving me a ton of information with relationship to the width. So I'm going to automatically start by writing my let statement to say let W equal the width. And now I'm going to start to write a let statement for my length. But remember, you have to write it in terms of your width. So now we're going to go back to that original sentence. And it says that it's 3 shorter than twice the width. So we're going to start there. Twice the width means multiplication, and 3 shorter than is subtraction. Lastly, we were told to label our drawing. So the width is W, and then we have our twice the width and 3 shorter than that, and there's our picture. Example 3. Angelina is 5 years older than Maria. Who is based off of who? Angelina is blah 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 than Maria. So that tells me that Angelina is based off of Maria. So that means that Maria is my starting point. So I'm going to let M equal Maria. And now when I'm ready to write my let statement for Angelina, I'm going to incorporate Maria's age in. It says that Angelina is 5 years older than Maria. Older than would indicate addition. So that means we would take Maria and add 5. Example 4. Marie works 17 hours per week less than Anne. Who is based off of who? Marie, blah, 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 than Anne. So Marie is based off of Anne. So Anne is our starting point. So we can let A equal Anne's hours. And now we can start to figure out Marie's hours. Marie works 17 hours less than Anne. So if Anne worked A hours and Marie worked 17 less than that, that is a subtraction of 17. Example 5 says that the first angle of a triangle is triple the second angle. The third angle of the triangle is 12 more than the second angle. So we know from this problem that the first angle was based off of the second angle, and the third angle was also based off of the second angle. Since both the first and the third angles were based off of the second angle. That tells me that the second angle is my starting point. So I'm going to let x equal my second angle, and then I can go from there. So I'm now going to go back to my very first sentence and write an expression for my first angle. It says that the first angle is triple the second angle. Well, my second angle was x, and tripling means to multiply. So 3 times x is 3x. Now I'm going to write an expression for my third angle. And it says that the third angle is 12 more than the second angle. More than means addition. So my second angle was x, more than means addition, and I'm adding 12. So now we're supposed to label the angles inside the picture. The second angle was x, the first angle was 3x, and the third angle was x plus 12. Example 6 is very similar to example 5. I would like you to pause the recording and go ahead and try this one on your own. Whenever you're ready, press play and we will check it together. Okay, by now everyone should have had an opportunity to complete example 6, and we should be ready to check our work. The problem tells us that the first angle is 16 less than the second. The third angle is double the second. So we know that the first angle is based off of the second. And we know that the third angle is based off of the second. So very similarly to what we just did, the second angle is our starting point again. So we're going to go ahead and let x equal our second angle. And now we're going to go back to our very first sentence to figure out what our first angle is going to be. It says that the first angle is 16 less than the second. Less than indicates subtraction, so x minus 16. And then for the third angle, it says that it is double the second. Double indicates multiplication, so that would be 2x. So filling in the diagram, the third angle is 2x. The first angle was x minus 16, and the second angle was x. Example 7. Please go ahead and pause the recording whenever you are ready. Press play and we will go over the answer together. Okay, by now everyone should have had an opportunity to complete example 7. This problem told us that the length of a rectangle is 8 feet longer than half of the width. length is based off of width. That tells us that width is our starting point. So we're going to let W equal the width, and then we can go back to figure out what we will let the length be represented by. So it says that the length is 8 longer than half of the width. So starting with half of the width, that would be 1/2 W. Longer than would indicate addition, and it's longer than by 8. So we would have 1/2 W plus 8, and then I would simply fill in my diagram. So I'd have 1/2 W plus 8 and W for my width. Example 8, please read the problem, write your let statements, and as soon as you're ready, please press play and we'll check your answers together. Okay, by now everyone should have had an opportunity to complete example 8. It says that a theater manager was examining the records of attendance for last year. The number of people attending the theater in January was 1/2 of the number of people attending the theater in February. So that sentence told us that January was based off of February. The number of people attending the theater in March was 3/5 of the number of people attending the theater in February. That sentence told us that March was based off of the number of people in February. Use algebra to describe the attendance for each month. Since January and March were both based off of February, that tells us that my starting point is the attendance in February. And we can then use the attendance in February to figure out the attendance in January and March. So we will go back into the problem, and it says that January was 1/2 of the number of people that attended in February. If February's attendance was X, 1/2 of that would be 1/2 X. And then we will write one more let statement for March. And it says that in March, it was 3/5 the number of people in February. So that would be 3/5 X. And the last problem in this section is example 9. I would like you to read the problem, solve it on your own, and as soon as you are ready, please press play and we will go over the answers together. Okay, by now you should have had an opportunity to complete example 9. We are now going to go over the answer together. The problem said that the college dean noticed that in the spring, the number of students on campus was 2/3 the number of students on campus in the fall. That tells me that spring was based on fall. She also noticed that the summer, the number of students was 1/5 the number of students in the fall. So summer was based on fall. Use algebra to describe the number of students on campus in each of the 3 time periods. Since spring and summer were both based on fall, that tells me that fall is my starting point. So I'm going to say let x equal the number of students in the fall. And then I can work from there to figure out the number of students in the spring and the number of students in the summer. So the dean noticed that the number of students in the spring was 2/3 the number of students in the fall. So that indicates multiplication. So we'll have 2/3 x. And for the summer, she said it was 1/5 the number of students in the fall. So we would have 1/5 x. So again, everyone, writing our let statements is very, very important to being able to solve word problems, which is where we're headed. I want you to make sure that you can do this and that this makes sense to you. If you are struggling with this, please let me know and we'll talk about it together. Thank you.